In this video, I want to go through an example where we're given a joint probability distribution function, and it kind of has this strange looking support, and we want to find a marginal distribution for y. Okay, so we know that if we want to find the marginal distribution of y, then what I need to do is integrate over x. So from negative infinity to infinity, for the joint distribution, I want to take this and integrate over x. All right, so now coming up with the bounds for this integration, so f of x, or f of x and y, is 0 a lot of the time, right? It's only non-zero. It only takes this value 3/2 x when this support is held true, right? So when x is between 0 and 2, and when y is between 0 and x minus 1. So the most common error that I will see students make is they'll say, oh, well, x has to be between 0 and 2, and they'll write 0 and 2, and they'll integrate the joint distribution over 0 and 2. Now, the error in this is that you do not take into consideration that x is actually, it's not just between 0 and 2. It's at the same time, it also must be greater than whatever y is. Okay, so we need to take that into consideration. So don't do that. Don't fall into that trap. Remember, it's this and this that both must be true at the same time. So the best way to start these type of questions is to go ahead and draw a graph of your support. Okay, so this is a graph of the support. In other words, this is a graph of the values of x and y where the joint distribution takes non-zero values. Okay, all right, so let's see, x can be between 0 and 2, so here's 1, 2, and then y must be greater than 0. Okay, so greater than 0 is up here. Remember, this is y and this is x. And y must be greater than 0, and it must be less than x minus 1. Let's go ahead and draw where y equals x minus 1. So that's a line that has an intercept of -1, so that's down here, and then a slope of 1. Okay, so here's 1, here's 2. So it goes onwards like this. Okay. This line here, this is the line y equals x minus 1. All right, so y must be less than this line and greater than 0. So less than this line, so here it equals the line. So remember, y moves in this direction. So less would be downwards, right? So it's got to be down here. Okay, so y has got to be down here in this area. Remember, at the same time, x has got to be less than 2. So actually, we cut it off. Let me use a dotted line for that instead. So it gets cut off here, and actually both these criteria, x between 0 and 2 and y between 0 and x minus 1, is only met here in this dark yellow area. Okay, so let me go ahead and clean this up. All right, so this is the line right here. Okay, all right, so only in this bright yellow area does the joint distribution take non-zero values. Okay, so this is the graph of the support. Very important that you understand and that you're able to graph this. Okay, it's really easy when you have x between 0 and 2 and y between 0 and 2. Then it's just like a little square, right? So that's nice and easy. But it gets really complicated when you end up having something like what we're seeing here, where x and y are actually depending on each other, okay, and inside their support. All right, so now when I want to when I want to integrate over x, I want to consider where x is taking values that are going to make this function non-zero. So let's think about this. Remember, x moves in this direction. So x looks like x is going from this line all the way up into 2. All right, and now this line right now, it's written with regards to y. So let me rewrite this line with regards to x. So this, if I were to, let's see, subtract y from both sides, add, or let's see, if I were to add 1 to both sides, that would get x on 1. So x equals y plus 1. Right? I add 1 to both sides, that gets x by itself. So this is the same line, right? X equals y plus 1 is exactly the same line as y equals x minus 1. The reason why this is important is because when I'm integrating over x, I'm going to want to figure out what the values of x takes. Okay, so it looks like x is taking values y plus 1 all the way until we get to 2. All right, so x isn't taking values all the way down to 0, right? Down here, this is not inside the support, so I cannot write my bounds from 0 to 2. That would be wrong, right? Over here is not in the support. No, it only picks up right here when x is y plus 1. Y plus 1 to 2, right? So I should write this integral y plus 1 to 2. All right, 3 halves x dx. All right, and then from here, this is going to be pretty straightforward calculus. Let's go ahead and do it together. The hardest part is thinking through the support. All right, so let's go ahead and finish this problem though. So I'll go ahead and make this x squared 3/4 from y plus 1 to 2. Okay, and then I'll go ahead and plug in my bounds. So I'll have 3/4 times 4 minus y plus 1 squared. Okay, so I'll have, this will cancel, so this will be 3 minus 3/4 y plus 1 squared. All right, and I could simplify this a little further if I wanted to. So this is 3 minus 3/4 y squared minus 2 y. Okay, I'll do plus 2y plus 1 and then distribute that 3/4. 3/4 y squared plus minus 6/4 y minus 3/4. Okay, and I end up with negative 3/4 y squared minus 3 halves y minus 3/4 plus 12/4. I just brought that 3 over to this side so that I can simplify that. All right, negative 3/4 y squared minus 3 halves plus 9/4. Okay, and so this is the marginal distribution of y. All right, I need its support, right? And since we've integrated over x, the support for the marginal distribution of y, let's think about that. I've already integrated over x, so now I've projected this down to the y values. Okay, so I've taken out x. So it looks like y is going to go from 0 to 1. Okay, so y goes from 0 to 1, and it is 0 otherwise. All right, another way you could think about this is if x was at most 2, then when you do 2 minus 1, then you get y is between 0 and 1. All right, so that's my marginal distribution for y, and I have that funky support. So I hope this helped you think this through. It's very important. Your first step in these type of questions should be drawing your support.